Today we're going to talk about properties of real numbers. And the first property we're going to talk about is the commutative properties. Now, in the commutative property, you're going to notice that the order of your numbers changes around the addition or multiplication sign. And one way that I remember this is that I think of the word commuting. Now, when you commute from home to school, you're changing your location. You started out at home, went to school, and when you commute back, you go from school to home. So think of commuting as the numbers changing around the plus or multiplication sign. So to rewrite this expression using commutative property, we just switch the order of the 7 and the 24 and write 7 plus 24. In this next problem, we're going to switch the order of the 5 and the negative 3. So we write 5 times negative 3. And that's the examples of the commutative property. In the associative property, the parentheses around the numbers change. Now, if you think of associations as groupings of people, then the associative property is letting you change the way that the numbers are grouped. In one side of the equal sign, the parentheses are around the first two numbers, and in the other side, they're around the last two numbers. Notice that the order of the numbers does not change, only the grouping in the parentheses. So rewriting this expression with associative property lets me put the parentheses around the 7 plus 9. It says 2 plus 7 plus 9 equals 2 plus 7 plus 9. Similarly, over here in this second problem, we're just going to move the parentheses and change them, and they'll be around the 6 and the a. So 6 times a is in a parentheses, and then times b. The distributive property is a property we're going to use quite a bit in this class. It allows us to multiply a number throughout a parentheses. And you're going to see that in both of these, the a is being multiplied times all the terms inside the parentheses. So in our first problem, we're going to multiply the 4 times the 5 and times the negative 3. So we write 4 times 5 minus 4 times 3. And then we use order of operations and we do our multiplications first. 4 times 5 is 20, 4 times 3 is 12, and 20 minus 12 is 8. Now I want you to see how our distributive property works. And we're going to do the problem a little bit differently. We're going to do the same problem, but we're going to use our order of operations, which tells us to simplify the parentheses first. And 5 minus 3 is 2, and 4 times 2 is still 8. So you see our distributive property does work, give us the same answer. And we use the distributive property when we have variables. So this negative 1 is going to get multiplied times x and times the 7. So you're going to see how I've distributed the negative 1 throughout. And negative 1 times x is going to give us a negative x minus and negative 1 times 7, which is negative 7. Now we have a subtract a negative, and as you know, that's the same as adding a positive, so we're going to change those signs. And our final answer is negative x plus 7. Now in our next problem, our negative 2 is behind the parentheses, but we're going to go ahead and still distribute it. Distribute that negative 2. So I like to put these little arcs just to kind of keep things straight. So we're going to write 3 times negative 2 minus x times negative 2, and 3 times negative 2 is negative 6 minus x times negative 2 is down negative 2x. Again, we have subtract a negative, so that's the same as adding a positive. And so we simplify this negative 6 plus 2x. We have a few more properties here. This one says this is the identity property of 0, and it says that if you add 0 to any number, you get the same number. That makes sense just from things you've done every day. but let's just write it here as a property. So example would be that if I take 0 and add 3 to it, I get a 3. Similarly, if I take my variable x and add 0 to it, I get x. So that's the identity property of 0 that lets you do that. 1 works the same way but with multiplication. When you multiply 1 in any number, you keep your number. So example would be 1 times 4, which we know is 4. And with variables, if I switch the order, it doesn't matter because y times 1 is still going to be y. So that's the identity property of 1. We're also going to talk about the additive inverse of a number. We know that as being the opposite of a number. So to get the additive inverse of a number, we're just going to switch its sign. So 2, its additive inverse would be negative 2. Also notice that a number plus its additive inverse will give you 0 always. So 2 plus a negative 2 is 0. And that's another property of additive inverse. Okay, and negative 3, its additive inverse is positive 3. All right. Another kind of inverse that we use is our multiplicative inverse. We know that as the reciprocal. And you know that with your work with fractions that you just flip a number upside down and that's its reciprocal. So for the number 2, the multiplicative inverse or reciprocal will be 1/2. And for the number negative 1/3, its multiplicative inverse is negative 3 over 1. Notice how we keep the sign, so they're both negative. And negative 3 over 1 is negative 3. Anytime you multiply a number times its reciprocal, you should get a 1. So that's a good check. Alright, now we have a series of problems. We're going to see which property. And a plus b equals b plus a. Notice that our order has changed. Our numbers have changed locations. So that's our commutative property. And this time it's of addition because we have the plus sign. The second problem, again, our numbers have changed orders from left to right. And when you look at the problem from left to right, a and b have switched order, so that's a commutative property again of multiplication. Problem number 3, the order of the numbers are the same, but the parentheses have changed. The groupings have changed. That's our associative property. And this will be associative property of addition, since we're dealing with pluses. Okay. In problem number 4, again, the order of the variables is the same in the left side and the right side of the equal sign, but the parentheses orders have changed. So that's your associative property again. This time for multiplication. Now it says here addition and multiplication are commutative as we've seen, but blank and blank are not. So remember, that means if you switch the order around the addition and multiplication sign, you still get the same answer. And also with addition or multiplication, but not with subtraction or division. So these are not commutative. So let's look at an example of that. Okay, with addition, if I write 3 plus 2, I get 5. And if I switch the order and I add 2 plus 3, I still get 5. That's why we say addition is commutative. But if I subtract 3 minus 2, I get positive 1. And if I switch the order, 2 minus 3, this time I get a negative 1. So notice how switching the order doesn't give me the exact number because the signs are different. So these are not equal, and that's why subtraction is not commutative. Division works the same way. We'll use that for the next problem. The next problem says addition and multiplication are associative, but blank and blank are not. So that means grouping numbers and adding will not give us, in different orders, will give us the same answer. Multiplying, same thing, but subtraction and division, no. So let's look at that example. Let's use the division. Okay. If we have 8 divided by 4 in a parentheses and then divided by 2, well, 8 divided by 4 is 2, and 2 divided by 2 is 1. So now let's switch the parentheses. Let's put the parentheses around the last two numbers, and remember that our order of operations says we have to do those parentheses first. So we're going to divide 4 by 2, and that gives us 2. Let's rewrite the 8, and so then 8 divided by 2 is 4. So notice how moving the parentheses we got two different answers. Okay, and then problem number 7. I bet you recognize this. This is the distributive property. We've distributed the A throughout the parentheses. And in problem number 8, same thing, distributive property.